students, hope you are doing well. Welcome to my channel where we nurture and learn mathematics beyond boundaries. In today's video, we are going to solve questions related to cost and revenue functions using the basics of integrals as per the curriculum for class 12 applied maths. The questions have been picked up from CBSE Handbook, M.L.Agarwal and even the PYQs for applied maths board exams. So before we get into solving questions related to cost and revenue, I hope you have watched the videos on indefinite integrals, definite integrals and the basics of cost and revenue functions. If not, pause this video right now. The links of all the 3 videos are there in the description. Go and watch all the 3 videos and then come back to solving questions related to cost and revenue functions. Now let's do a quick recap of what is cost and what is revenue. Cost is the investment that you make in any business. It is a function of the amount of units that you are going to produce. And when we differentiate cost, we get the marginal cost, and when we do the inverse, we integrate the marginal cost, we get the cost function. Similarly, revenue is also a function of the quantity that is to be produced. Revenue is price into quantity. So when we differentiate revenue, we get marginal revenue, and when we integrate marginal revenue, we get back the revenue function. Cost is composed of 2 components, variable cost and fixed costs, and revenue is the product of price and quantity. Average cost is total cost divided by the quantity, and average revenue is total revenue divided by the quantity. So we have already talked about all the basics of these. Demand and what is profit, what is demand, price is not demand, price is different, demand is different. Then we also had a look at what is price, what is profit. Profit is revenue minus cost. So now let's start with solving questions related to cost and revenue. The first question is the marginal revenue of a company is given by MR is equal to 80 plus 20x plus 3x square, where x is the number of units sold. Find the total revenue function if at x is equal to 2 or x is 240. So we start with integrating the marginal revenue, that is 80 plus 20x plus 3x square. Do not forget to put these brackets and write dx here. Now let's integrate. It is a simple polynomial function which can be easily integrated. So it becomes 80x plus 20 x square by 2 plus 3 x cube by 3 plus the constant of integration. 3 gets cancelled, even 2 gets cancelled. So that means the revenue function now is x cube plus 10x square plus 80x plus k. Now there is an additional condition given in the question that when x is 2, so right here, when x is 2, the revenue is 240. So that means when we put these values, 240 becomes equal to 2 cube plus 10 into 2 square plus 80 into 2 plus k. So these conditions like these present in the question, they help you to find the value of the integration constant. So 240 is equal to 8 plus 40 plus 160 plus k. So this becomes 208. That means k is 240 minus 208, and that comes out to be 32. So that means the total revenue function is given by x cube plus 10x square plus 80x plus 32. So this is my final answer. Easy? Wonderful. So let's move to question number 2. The weekly marginal cost of producing x pairs of tennis shoes is given by 17 plus 200 upon x plus 1. If the fixed cost is rupees 2000 per day, find the cost function. Now again we need to find the cost function. So we start by integrating the marginal cost function, which is 17 plus 200 upon x plus 1. Again, do not forget these brackets and dx. Now this is again a very simple polynomial which can be integrated. So the integral is 17x plus 200 is the constant, keep it aside. Integral of 1 upon x plus 1 is what? 1 upon x is log x. So 1 upon x plus 1 will be log of x plus 1 and then the constant of integration. So this is the cost function. Now the question says if the fixed cost is rupees 2000. So if the fixed cost is rupees 2000, what does this mean? This means when x is 0, So when x is 0, the value of the cost function is 2000. So that means we need to put these values in the cost function and find the value of k. So now this becomes 2000 equals 17 into 0 is 0 plus 200 log of 0 plus 1 is log 1 plus k. Log 1 is 0, so this term also becomes 0. That means the value of k is 2000. So that means the total cost function is 17x plus 200 log of x plus 1 plus 2000. So this is the final cost function that we get. Done? Easy? Wonderful. So let's come to the next question. If the marginal cost of production of a commodity is 30 plus 2x, it is known that the fixed cost is rupees 200. Find the total cost function and the cost of increasing the output from 100 to 200. So first let's find the total cost function by integrating the marginal cost function, which is 30 plus 2x. So when we integrate this, we get 30x plus 2x square by 2 plus the constant k. So that means the cost function eventually becomes x square plus 30x plus k. Now the question also says that the fixed cost is rupees 200. So when the fixed cost is given to you, this means when x is 0, the cost function becomes whatever value is given. Here in this case it is 200. So let's put these values into the cost function. 0 plus k. So that means the value of k is 200. So the cost function becomes x square plus 30x plus 200. Now you must be wondering why we are putting x is equal to 0 and equating the cost function to the given value. Why can't we straight away replace k with the constant value? Because in both the cases we got k as the same value that was given in the question. But in some questions, k is not directly the same value, the fixed cost that is given in the question. So we'll see further in subsequent questions that k may not always be equal to the fixed cost given in the question. So we cannot directly replace k with the fixed cost. So you need to use this condition when the fixed cost is given. That means when x is 0, when no production is done, that means the costing is equal to whatever fixed cost is given to you. Okay, now the second part is the cost of increasing the output from 100 to 200. Now there are two ways of solving this. Either you integrate the above marginal cost function using the limits, lower limit as 100 and upper limit as 200. Now because we have already done the integration, so we can directly put the values in this cost function and find the value of the cost function at both these points, that is 100 and 200. So when x is 100, the cost function becomes 100 square plus 30 into 100 plus 200. So this becomes 10,000 plus 3,000 plus 200, and that comes out to be 13,200. Now when the number of units produced is 200, the cost function is 200 square plus 30 into 200 plus 200. So this becomes equal to 40,000 plus 6,000 plus 200, and that comes out to be 46,200. So eventually the difference between the two values that we just calculated is what we need. So this is the increase in the cost when the production is increased from 100 to 200 units. So this is the cost involved. So that means this is equal to 46,200 minus 13,200, and that comes out to be 33,000. After this, don't leave it here. Write the answer statement with proper statement and unit. In this case, it is going to be the cost increase in the cost involved when the production is increased from 100 to 200 is rupees 33,000. So please do not forget the unit. Okay? Done? Wonderful. So let's move to the next question. The marginal cost of a product is given by 500 upon square root of 2x plus 25, and fixed cost is rupees 2,500. Find the total cost function. Also find the average cost of producing 72 units. So let's first find the cost function by integrating the marginal cost function. So this is the marginal cost function that is given to you. So let's first integrate this. Keep the constant aside. Now this can be written as 2x plus 25 whole to the power minus 1 by 2. And when we integrate it, it becomes minus 1 by 2 plus 1 is 1 by 2. So this is 2x plus 25 to the power of 1 by 2 upon 1 by 2 multiplied by another 2, that is the coefficient of x in this function. So the coefficient of x in this polynomial also needs to be taken here in the denominator, plus the constant of integration. Now this 2 gets cancelled and we are left out with 500 square root of 2x plus 25 plus the constant. So this is the cost function that we get. Now we are given the fixed cost. So again we'll use the same logic here. Fixed cost is rupees 2500. This means when x is 0, the value of the cost function is 2500. So let's put these values into this cost function. 2500 equals 500. Square root of 2 into 0 becomes 0. So it is square root of 25 plus k. Square root of 25 is 5. So 5 into 5 becomes 2500, and here also we have 2500 plus k, so that means the value of k here is 0. Now here the value of k is not equal to the fixed cost given in the question, it is 0 here. So always when you are given the fixed cost, use this logic here. When x is 0, the cost function is equal to the fixed cost that is given in the question. Now we have the value of k, that means the total cost function finally is this 500 into square root of 2x plus 25. So this is the total cost function. Next thing we need to find out is the average cost of producing 72 units. So what is average cost? Average cost is the total cost function divided by the quantity. So if I divide this by the quantity, this becomes by average cost, right? And now I need to find this average cost when the quantity of production is 72. So let's just put the value 72 here. 500 square root of 72. 72 into 2 is 144. 144 plus 25, 169. And square root of 169 is 13. So this becomes 500 into 13 upon 72. Now let's cancel it. 36, 250, 18 and 125. So we cannot cancel it further. So what do we get? How much is 125 into 13? It is 1625. So it is 1625 upon 18. So this is the average cost when 72 units are produced. Rupees 1625 upon 18. So please do not forget the unit again when you are writing the answer statement. Okay, let's move to the next question now. The marginal cost function of producing x units of a product is given by MC is equal to 3 e raised to power 0.3x plus 5. If the fixed cost is 6050, find the total cost function and also find the cost of production of 10 units. So again we need to start finding the total cost function by integrating the marginal cost function, which is 3 into e raised to power 0.3x plus 5. So this is the marginal cost function. So let's integrate. 3 is the constant by the side. Integral of e raised to power x is e raised to power x, but here it is 0.3x. So divided by 0.3, coefficient of x. Integral of 5 will be 5x plus k, the constant of integration. Now let's simplify this. 0.3 can be written as 10 by 3, so 3 gets cancelled and we have 10 e raised to power 0.3x plus 5x plus k. So this becomes the cost function. Now we are given that the fixed cost is rupees 6050. So fixed cost is rupees 6050. This means again the same logic. When x is 0, the value of the cost function is 6050. So let's put these values into the cost function. 6050 equals 10 e raised to power 0.3 into 0 plus 5 into 0 is 0 plus k. E raised to power 0 becomes 1. So that means this is 10 plus k, and this gives the value of k as 6040. So this means that the total cost function is 10 e raised to power 0.3x plus 5x plus 6040. So this is the final total cost function. Do we need to find something else? Find the total cost function and also find the cost of production of 10 units. So when we have the cost function, we just need to put x as 10. So let's find the value of this cost function when x is 10. So it becomes e raised to power 3 plus 5 into 10 is 50 and then 6040. Now we do not know the value of e raised to power 3, so we'll leave it as it is, 10 e raised to power 3 plus 6090. So this is the cost involved when the number of units produced is 10. Understood? Great. So let's move to the next question. The marginal cost function of producing x units of a product is given by x upon square root of 2500 plus x square. Find the total cost function and the average cost function if the fixed cost is given to you. So again we start with integration of the marginal cost function to get the total cost function. Now how do we integrate this? Now here in this case the numerator is a variable, it is not a constant. If it was a constant, we could have done it the way we have done earlier. Now here, because the variable is a constant and we need to figure out what pattern the question has and what method should we use here. So here in this question we need to use substitution. Let's put 2500 plus x square as t. So this becomes 2x dx equals dt. So x dx can be replaced by half of dt. So let me keep that half outside, and within the integral I have this dt upon square root of t. Now what is integral of t? T to the power minus 1 by 2, minus 1 by 2 plus 1 becomes 1 by 2, and we have half is already out. So t to the power 1 by 2 divided by 1 by 2. This 1 by 2 gets cancelled, and we have the cost function as square root of t plus k. So let's replace t with the original function in terms of x. So it becomes 2500 plus x square whole under the root plus k. So this is the cost function. Now the question was find the total cost and average cost if the fixed cost is rupees 1000. So again, when you are given fixed cost as rupees 1000, you will write this means when x is 0, the cost function has a value of 1000. So let's put these values into the cost function and find the constant of integration. So this becomes square root of 2500 plus k. Square root of 2500 is 50. So let's bring 50 to the other side. K becomes 1000 minus 50, and that is 950. So that means the total cost function is square root of 2500 plus x square plus 950. So this is my total cost function. Do we need to find something else? Total cost function and the average cost function. So now what is average cost? Average cost is total cost divided by quantity. So you just need to write the same expression, 2500 plus x square under the root whole upon x plus 950 upon x. So this is the average cost function. Clear? Easy? Wonderful. So let's come to the next question. The marginal cost of producing x units of a product is given by x square root of x plus 1. The cost of producing 3 units is 7800. Find the cost function. Again we need to use integration of the marginal cost function, which is x into square root of x plus 1 dx. Now how do we integrate this. Look at the pattern of the question. Is it fitting into any of the patterns? Partial fractions, no. Parts, no. Substitution, yes, maybe. So let's try. So let's put x plus 1 as t, dx is dt, and from here we have x equals t minus 1 also. So this becomes integral of, in place of x I can write t minus 1 and square root of t and dt. Now let's open the bracket, it becomes t to the power 3 by 2 minus t to the power half and integral of this entire thing with respect to t. So we have, when we integrate t to the power 3 by 2 plus 1 is 5 by 2. So that means 2 by 5, t to the power 5 by 2 minus half plus 1 becomes 3 by 2. So it is 2 by 3 and then t to the power 3 by 2 plus the constant of integration. So eventually we replace x back with the function of x whatever we have substituted. So 2 by 5 x plus 1 to the power of 5 by 2 minus 2 by 3 x plus 1 to the power of 3 by 2 plus the constant of integration. This becomes the cost function. The cost of producing 3 units is 7,800. So the question also says when x is 3, the value of the cost function is 7,800. So let's put these values into the cost function. 7,800 equals 2 by 5, 3 plus 1 becomes 4. 4 to the power 3 by 2 minus 2 by 3, 3 plus 1 is again 4, 4 to the power 3 by 2. Sorry, here it is 5 by 2, not 3 by 2. Plus the constant of integration. Now how do we evaluate 4 to the power 5 by 2? This can be written as 4 to the power half whole to the power 5. This means square root of 4. Square root of 4 is 2 and 2 to the power 5 is 32. 2, 4, 8, 16, 32. So that means this becomes 2 by 5 into 32 minus 2 by 3 into, how do we calculate 4 to the power 3 by 2? 4 to the power half whole cube. So square root of 4 is 2 again and 2 cube. 2 cube is 8 plus k. So this is equal to 64 upon 5 minus 16 upon 3 plus k. That means k is equal to 7,800 minus 64 upon 5 plus 16 upon 3. Now let's solve this. Just take the LCM and find the value of k. So the LCM is 15 and then you get 117,000 here minus 192 plus 80. And when you solve this, you get 116,888 by 15. So this is the value of the constant of integration. This means eventually the total cost function comes out to be 2 by 5 x plus 1 to the power of 5 by 2 minus 2 by 3 x plus 1 to the power of 3 by 2 and the constant of integration, that is 116,888 by 15. So this is the total cost function. Understood? Great. So let's come to the next question. The marginal revenue function for a firm is given by 5x square plus 30 plus 51 upon x plus 3 whole square. Show that the revenue function is given by this expression. So again we start with integrating the marginal revenue. So finally we had revenue, something on revenue rather than only cost all the time. So 5x square plus 30, it is 30x here. 5x square plus 30x plus 51 upon x plus 3 whole square. Now how do you integrate this function? If you look at it, it is a polynomial function. What kind of function is it? Polynomial. Whenever you have a polynomial with the degree of numerator equal to the degree of denominator, what do you do? Just recall from indefinite integrals, what do you do when the degree of numerator is same as degree of denominator? We use long division. How do we do that? 5x square plus 30x plus 51 to be divided by x plus 3 whole square is x square a square plus b square plus 2ab. So if I expand this, this is what I get. Now let's divide these two polynomials. 5. So this becomes 5x square, 5 6 are 30, 30x, 5 9 are 45. Change the sign and these get cancelled. So the remainder is plus 6. So that means this integrand can be written as the quotient by the sides plus remainder upon the divisor. Now it is easier to integrate. So let's integrate it. 5x plus, keep the constant by the side. So this is integral of x plus 3 to the power minus 2 dx, right? So this becomes 5x plus 6, and what is the integral? Minus 2 plus 1 becomes minus 1. So that means it is minus 1 upon x plus 3 and then the constant of integration. This is the revenue function. Now we have to prove that the revenue function is given by 5x plus 2x upon x plus 3, but we don't have the same expression here. So that means when you are given no condition for the revenue question, you need to use the logic that the revenue will be 0 when x is 0. So let's put it as 0. 5 into 0 is 0, minus 6 upon 0 plus 3 becomes 3 plus k. 3 2s are 6. So that means the value of this constant is 2. Let's put the value of this constant and simplify it little bit. 5x minus 6 upon x plus 3 plus 2. So this is the revenue function. But we need to prove a little different expression, 5x plus 2x upon x plus 3. So that means you leave this 5x aside and club both these terms. So you get 5x plus, take the LCM, x plus 3. I have deliberately made this plus. So first I will cross multiply x plus 3 by 2. So this is 2x plus 6 minus 6. So eventually you get 5x plus 2x upon x plus 3, which is the same expression that is given to you in the question here, 2x upon x plus 3 plus 5x, right? Okay, wonderful. So let's move to the next question. Find the total revenue function and the demand function if the marginal revenue function is given by AB upon x plus b whole square minus c. Now here the marginal revenue is given in terms of certain arbitrary constants rather than constants. So let's start by integrating this marginal revenue function AB upon x plus b whole square minus c, put it into brackets and then dx. So how do we integrate? Keep the constant aside. Now this is x plus b whole square. Integration of x plus b whole square. The exponent is minus 2. Minus 2 plus 1 is minus 1. So that means the integral of this expression is minus 1 upon x plus b. And the integral of c is cx plus next the constant of integration. Anything else given in the question? Nothing. So that means now we are going to use the condition when x is 0, the revenue is 0. So let's put these values here. So it is minus AB upon x is 0, 0 plus b is b, minus c into 0 is 0 plus k. So that means the value of k is equal to a, right? Now let's put the value of k in the revenue function. It is minus AB upon x plus b minus cx plus a. Let's club these two terms the way we have done in the previous question also. So this becomes minus ab plus ax plus ab upon x plus b and then minus cx. ab gets cancelled and then we have the total revenue function given by ax upon x plus b minus cx. So this is your final answer. Understood? Superb. So let's move to the next question. The marginal revenue of selling x units of a commodity is given by MR 20. MR is equal to 20 e raised to power x by 10, 1 plus x upon 10. If the revenue obtained on selling 10 units is rupees 200 e, find the revenue function. Again we need to find the revenue function first by integrating the expression given here, 20 e raised to power x upon 10, and this is 1 plus x upon 10. Now pause this video right away and think how to integrate this function. If you are thorough with the basics of indefinite integrals, you can integrate this very easily. Just think what kind of expression it is. It has e raised to power x by 10 and there is another function. So you are going to integrate by parts. We need to use integration by parts here. So this is the first function, algebraic function, and this is the second function, that is the exponent function. I hope you remember ILATE. So we have exponent at the end and we have algebraic functions before exponents. So let's integrate this. I'll keep 20 outside, the constant is outside, and within the brackets, how do we integrate? First function into integral of second function minus integral of derivative of first function into integral of second function. Don't forget these brackets and another dx here, right? So let's start to simplify this expression. So this becomes 1 plus x by 10 will remain as it is. Integral of e raised to power x by 10 is e raised to power x by 10 divided by the coefficient of x, which is 1 by 10, minus integral of, what is the derivative of this? Derivative of 1 is 0, x by 10, the derivative is 1 by 10. Then integral of e raised to power x by 10 is e raised to power x by 10 divided by 1 by 10. So we need to integrate this expression once more. So what do we have? 20, 1 plus x upon 10, and this becomes 10 e raised to power x upon 10 minus, what is the integral? This 10 goes up, 10 gets cancelled, and let's integrate. So this becomes e raised to power x by 10 upon 1 by 10 once again, plus the constant of integration. So eventually what do we get here? 20 is outside, 1 plus x upon 10 into 10 e raised to power x upon 10 minus, this becomes 10 e raised to power x upon 10 plus the constant of integration. You can keep the constant of integration outside these square brackets, it doesn't matter. Next, okay, can we take out 10 e raised to power x by 10 common outside? So this becomes 200 into 10, 20 into 10, 200. 200 e raised to power x by 10 is gone out. What is left out from the first expression, first term? So it is 1 plus x by 10 that is left out, and here from here, because 10 e raised to power x by 10 goes out, so we have just minus 1 plus the constant of integration. 1 and 1 gets cancelled, so we have 200 e raised to power x by 10 into x upon 10 plus the constant of integration. So the final function is 20 e raised to power x by 10. So we can write x here. So it is 20x e raised to power x by 10 plus k. So this is the final revenue function that we got. Now additionally the question says if the revenue obtained on selling 10 units of the commodity is 200e. So let's put these values. The revenue for 10 units is 200e. So you are given revenue for 10 units is 200e, right? So that means 200e equals 20 into the value of x is 10 into e raised to power 10 upon 10 plus the constant of integration. 10 by 10 becomes 1 e raised to power 1 e, and this is 20 into 10 becomes 200. 200e, and here also we have 200e plus the constant. So this means the value of k is 0. Right? So that means the final revenue function is 20x e raised to power x upon 10. So this is the total revenue function where the constant is gone now. Do we need to find anything else in this question? Find the revenue function, that's it. So that means this is your final answer, 20x e raised to power x by 10. Understood? Wonderful. Okay, now pause the video and try to attempt this question on your own. It is very easy and you can do it. If you are unable to do it, you can definitely continue. So let's solve this question. The marginal revenue of the product is given to you, where x is the number of units. Based on the information, answer the following questions. Find the revenue function. That means the first thing that we need to do is integrate the marginal revenue function that is given to you. So this is the marginal revenue function. Let's integrate 7x minus 4x square by 2 plus 3x cube by 3 plus the constant of integration. 3 gets cancelled and this 2 also gets cancelled. So we get 7x minus 2x square plus x cube plus k. This is the revenue function. This is part A. Next, B part says if x is 4. So when x is 4, the revenue generated is 20. So that means we need to use this information to find the value of the constant. So 20 is equal to 7 into 4 minus 2 into 4 square plus 4 cube plus the constant of integration. So 7 4s is 28 minus 16, 16 2s are 32 plus 4 cube is 64 plus k, and we have 20 here. So when we solve these values, we get the value of k as minus 40. So that means the revenue function is now x cube minus 2x square plus 7x minus 40. So this is the total revenue function. Fine. Let's look at part C. Find the demand function. Now what is demand? Demand is revenue upon quantity produced, right? So we divide each term by x and it becomes x square minus 2x plus 7 minus 40 upon x. So this is the demand function. That's it. Easy? The last part is find the average revenue. How do you find the average revenue? Average revenue is total revenue divided by quantity. So what is the total revenue? Again, if you divide each term by x, you get the same expression as you got for the demand function. So in this case, the demand function is same as the average revenue, right? So I hope it was easy. Now let's come to the PYQs for cost and revenue functions. The first question is if the marginal revenue function for output x is given by some expression, find the total revenue. It's very easy. You just need to integrate the given expression to find the total revenue. Now the question is 6 upon x plus 2 whole square plus 5. Integrate this with respect to x. So this integration is easy. 6 is a constant by the side, x plus 2 to the power minus 2. So this expression becomes minus 1 upon x plus 2 plus 5x plus the constant of integration. So are we given any other condition? No. Minus 6 upon x plus 2 plus 5x plus k. Now because we are not given any other condition, so we'll use when x is 0, the revenue is also 0. So that means 0 equals minus 6 upon 0 plus 2 is 2 plus 0 plus k. So this means the value of k comes out to be 3. So the final revenue, the total revenue function becomes minus 6 upon x plus 2 plus 5x plus the constant of integration, that is 3. Ideally you should club these two terms, the constant of integration and this expression. So it becomes 5x plus, let's take the LCM. So it becomes 3x plus 6 minus 6. And the final answer is 5x plus 3x upon x plus 2. So this is the total revenue function. So I hope you understood till here. Let's move to the next question. Now this question is part of the CBSE sample paper for the year 2025-26 and it uses the concept of both differentiation and integration. So let's see. A company has approximated the marginal cost and marginal revenue functions for one of the products as MC and MR that is given to you. Determine the profit maximizing output and the total profit at the optimum output assuming fixed cost is 0. So how do we solve this question? What is profit? Profit is revenue minus cost. Now we need to find the profit maximizing output. That means first let's find the profit. What is the marginal cost given to you? It is given to you something and marginal revenue is also given to you. So to maximize the profit, let's first find marginal profit, which is equal to marginal revenue minus marginal cost. So it is going to be 20x minus 2x square minus 81 minus 16x plus x square. Let's open the bracket and simplify. So minus 2x square and minus x square becomes minus 3x square. 20x and 16x is 36x and minus 81. So this is dp upon dx, marginal profit. Now the question says determine the profit maximizing output. So when is the profit going to be maximum? How do we find that? Equate dp by dx to 0 and then find the value of x. So if I put this as 0, minus 3x square plus 36x minus 81 equals 0. Let me change the sign of all the terms so that the coefficient of x square is positive. So let's change the sign. Basically I am shifting everything to the other side. Divide the entire equation by 3. So it will be minus here. So divide this entire equation by 3 now. We get x square minus 12x plus 27. Now we can split the middle term and factorize and get two values, x minus 9 into x minus 3 equals 0. So that means the two values of x are 3 and 9. Now which of these two values is going to give you maximum profit? How do we find out? We find the second derivative of the function that we have here. So that means if I find d square p by dx square, it is going to be minus 3 into 2x plus 36. So it becomes minus 6x plus 36. So this is the second derivative. Now let's have a look at the question again. Determine the profit maximizing output and the total profit at the optimum output assuming fixed cost as 0. So that means this is any value of x given here. So now we get this as the second derivative, d square p by dx square is equal to this. Now let's find this value at both the values. X is equal to 3. When x is 3, what is the value of d square p by dx square? And when x is 9, then what is the value of d square p by dx square? We just need to look at the sign to understand when it is maximum or when it is minimum. So question says when the profit is maximized. So let's put x as 3 here. So you are going to get it as 6 3 is 18 minus 18 plus 36. So it is plus 18. That means this is not the condition we are looking for. Let's put x as 9. 6 9s are 54 minus 54 plus 36. In this case we have less than 0. So when the second derivative is less than 0, that means the profit is maximized at x is equal to 9. So the profit is maximum when the value of x is 9. Now because we have derivative, the first derivative is, what is the first derivative? Let's write the first derivative here. dp by dx is equal to minus 3x square plus 36x minus 81. right? Now if I put when x is 0, what is going to be the profit when x is 0? When x is 0, the profit is 0, that means the cost is also 0. So that means P is equal to this. We need to evaluate the profit function. How do we find the profit function? We can find the profit function by integrating dp by dx with respect to x and then putting the value of x as 9. That will give you the maximized profit. So let's integrate the marginal profit. So it is going to be integral of minus 3x square plus 36x minus 81 with respect to x. Integrate this, what do we get? We get minus 3x cube upon 3 plus 36x square upon 2 minus 81x plus the constant of integration. 3 gets cancelled, 2, 18. So that means we get, what is this total function? X cube plus 18x square minus 81x plus k. Now this is the profit function that we get. What all was asked in the question? Let's have a look at the question again. Determine the profit maximizing output. We got that as 9. And the total profit at the optimum output. So that means when you put x as 9, assuming fixed cost is 0. So there is no fixed cost. So we just need to evaluate this polynomial now by putting x as 9. So what is the profit at x as 9? 9 cube plus 18x square minus 81 into 9 plus the constant of integration. So how much is 9 cube? 9 cube is 729. It is minus here. So this will be minus 729. 9 square is 81. 81 into 18. 9 square is 81. This 18 can be broken as 2 into 9. So it becomes 9 cube into 2. So double of 729. So basically we have 2 into 729 for the second term. And the third term is 81 into 9. Again we have 729 plus the constant of integration. Now if we try to solve this rather than doing all the calculations, be smart enough. Minus 729 is 2 times 729 and we have plus 729. So that means all these terms get cancelled and the value of k comes out to be 0. Right? So the total profit, maximum profit here is 0, even though it is 0, but this is the maximum profit in the given scenario when 9 units of the product are produced. So I hope you understood all the questions, how they are to be attempted for cost and revenue functions, whether it was maximizing the profit or whether it was just finding the cost and revenue functions from the marginal cost and marginal revenue functions. If you like the video, if you found it useful, don't forget to click the like icon. Share the video with your friends. Subscribe to my channel if you have still not subscribed. Keep watching, keep learning, and do hit the bell icon so that you keep getting notifications for the upcoming videos. So keep watching, keep learning, and keep growing. Thank you so much.